Hi there, and welcome to today's webinar on next-gen NetFlow analysis, big data, open source, and SaaS, sponsored by Kentik. Today's presenter is Jim Frey, Kentik VP of Product Management. Now, Jim brings a lot of broad industry perspective on network management. His experience includes work as an industry analyst at Enterprise Management Associates, EMA, as well as executive roles at NetScout and Micromuse, and product management roles at Agilent and Cabletron. As a matter of logistics, please feel free to type in questions or feedback as we go along, and we're going to address the questions at the end. We'll have a little Q&A session. So with that, I'm going to turn things over to you, Jim.
Okay, thank you, Alex, and welcome everyone. Thanks for joining us. I think we have a very timely topic today to talk about what's going on with NetFlow analysis and what we really should be thinking we can and should be expecting to do to move the bar forward to think about how can we really get more out of NetFlow for the purposes of monitoring and manage our businesses and our infrastructures. So the things we're going to cover today, we're going to look at quick context setting, what's the current sort of usages that we see for NetFlow, and it's very much day in, day out. We look at this all the time. So I'm going to share a little bit of that. We want to then talk about some of the decision points that are facing folks who want to sort of move the needle, move forward to a more of a next-gen approach, try to figure out what more can be done with NetFlow. And we'll spend some specific time looking at big data and SaaS as some of the more recent technology. I'm not sure if I'm going to say innovations, but trends, and the role that they could play in this attempt to move to more of a next-gen approach. Then we'll talk a little bit about Kentik and what we do and how we've applied some of these technologies, so you can see what it looks like when we start to really leverage these kinds of approaches. And we'll save a little time at the end for Q&A. So first off, let me set context just for the few folks who might be on here who have never heard of NetFlow. I promise this will only be a very short portion. So those of you who know NetFlow well, feel free to go get coffee, but don't take too long before you come back. So NetFlow is flow records. They are documentation of activity on a network. They come across in a little summary record that is typically source and destination IP addresses, along with port and protocol and a few other details. And it really started out as a switching technology from Cisco Systems. That was called NetFlow back in the 90s. That has long ago been superseded by other switching technologies. But along the way, Cisco realized, hey, we need, for a control perspective, we need to understand every flow of traffic, every connection, every session that's going on, so that we can treat that appropriately from a switching perspective. And the metadata that was harvested as a result of that switching technology, it survived intact after even Cisco moved on to other approaches to switching. So that was the basis for NetFlow, and the reason why it's named after a switching technology. It certainly has been imitated and enhanced significantly since that initial origination. So what we see today now are a number of active variants of the concept of NetFlow. In a lot of the writing that I've done before coming to Kentik, I would call it generally XFlow because there are so many different variants. But it really kind of comes down to about 4 that are most commonly used today. We see a lot of NetFlow coming into our own back end. We'll talk about that later. But the top variants that we see, and I believe are truly representative of what's out there in active use today, are V5, V9, IPFix, and SFlow. Now, NetFlow V5 is still a static form of NetFlow record definition. There's a limited set of metrics that are transmitted using V5. It was really probably the first version of NetFlow that saw really broad adoption. The early versions, NetFlow V1 in particular, saw some usage, but there's been a lot more adoption and use of V5. And there are a number of V5 equivalents that you'll see in the forms of CFlow, JFlow, NetStream, quite similar imitations of this similar construct, generally static records. Now, the newer versions and variants are things like NetFlow V9, also known as Flexible NetFlow, and IPFix, which is also sometimes known as NetFlow V10. IPFix being the multi-vendor standard out there But both of these are templated. And by templated, what I mean is we now have an ability with these flow record types to send a variable grouping of information and go far beyond the original fixed templates that were part of V5 or fixed record structures. And this is going to allow us to do some really interesting things in terms of more augmentation of transmitting more data from flow sources, which are typically devices in the infrastructure, can be NetFlow generating probes as well, but much more richness of information now available via this technique. SFlow is worth a few mentions as well here. SFlow is a statistically sampled flow technology, actually quite interesting from the standpoint of it being very deterministic in terms of the sequence and expectations about when you will get data records. And that can be very, very valuable for narrowing the time window for recognizing activity. The other types of flow records are all, generally speaking, they are pushed out when a flow happens or when a flow terminates or on some sort of fixed timer. But as a result, they can be a little bit lumpy when you start looking down into very narrow time windows. SFlow, on the other hand, is very deterministic and comes on a very regular basis. Now, the pie chart you see on the right there is the actual documentation of what we see coming into Kentik's production environment in terms of a mix of these types of flow records. We are generally gathering flow, or we are gathering flow today across a number of our customer managed environments that have Brocade, that have Cisco, that have Juniper, mix of types of devices, but the formats we see coming in are really kind of mixed as well. Mostly SFlow, interestingly, or at least the largest slice, but not a majority. But then a good mix of some V5 out there still being used, some V9, about a quarter that's IPFix. Now, this was from early December when I compiled these statistics, and it keeps changing every day. So I will take a look at how this changes over time. We'll be fascinated to watch how that evolves, and maybe we'll publish some blogs about how that's changing. Now, with that sort of context and understanding of what we're talking about when we talk about NetFlow, and I'm going to use NetFlow as a general term because that's what most people think of. And apologies to sflow.org. I'm not trying to diss you, but we'll generally call this NetFlow going forward for this presentation at least. Now, the good, the bad, and the ugly. What is this really good for? What's it not so good for? The best things we see it being used for is cost-effective, broad-based monitoring of distributed infrastructures. It's really highly cost-effective as a technique for harvesting information about what's going on in the network versus primarily the other rich specific type of source, which would be packet inspection. Packet inspection does other things that you cannot do with NetFlow. We'll talk about that in a second. But flow records really, I think, are the most cost-effective for broad visibility. It also actually is a great way to very quickly understand in a lightweight manner all of the activity, and that has specific values for certain use cases around security in particular. So the things that it doesn't do quite so well, because it's not actually harvesting and keeping payloads, it's not very good for forensic recreation. So you can't recreate or replay a web session or a VoIP phone call out of NetFlow because the payloads aren't there. So if you want to be able to do that, you do need to have a way to, for instance, stream a complete copy of packets to disk so that you can run replay forensics. It also doesn't particularly handle really narrow time horizons well, and this would be a case where you've got a very high volume of very small, short-lived packets. Oftentimes, the problems that occur in this sort of scenario are called microbursts, and the time horizons of these things are in the tens of milliseconds. So you can still use NetFlow data to help with some characterization of these things, but it is oftentimes not ideal for catching and really digging into the causes of microbursts. So some things that are getting better, and I think this is what makes it really exciting. Most people still think about NetFlow as V5, as a subset of the information that's available out there, but it's really not the case anymore. There is a lot of additional data that can now be transmitted through this medium. Some of them include things like going beyond the original traffic documentation that is NetFlow to start adding metrics around actual network performance. So by this, I mean things like retransmits, things like network errors, things like packet drops and packet loss, things like round trip time. These help you understand not just how much is going across the network, but how well is that being delivered and what problems are there that are arising because of that. You can intuit some of that from the traffic patterns without those metrics, but it's far more conclusive if you can have access to those. And those data points, those measurements can now be added into NetFlow records. And you can get them now from multiple places around your infrastructure as a result. The other, and I think one of the most fascinating areas for the future, is adding additional layers of detail about specific application activity and performance metrics into flow record formats. So adding more awareness of application activity from the network perspective is the key to tying network traffic to the business, because the business operates on applications. It does not, unless you are a network service provider, and I don't want to disrespect those of you who are on here who are. If you are an enterprise or you are a commercial organization relying on the network and the internet, you live and die by the applications that you have running across there. And so the more connection you can make between those applications and the activity and performance across the infrastructure, the network infrastructure, the more likely you are to be able to recognize and prioritize issues appropriately. So NetFlow, has been a solid basis for certain functions and use cases, and those are evolving as we see them based on these sort of new capabilities. So I want to talk about also what we see today as really, I think, the top 3 use cases for NetFlow harvesting and analysis. And this is going to be important as we think about where we're going for the next generation. So I'm going to just build these out real quick before I tell you why I have stars on a couple of these. So network operations, absolutely an active use case where you're looking at monitoring, you're looking for problems you can raise alerts on, and you're using it for some aspects of troubleshooting. You can't necessarily do all deep troubleshooting, but NetFlow still is very good for helping you with triage, helping with localization, and therefore is relevant for network troubleshooting. Another use case that's very common and has a lot more history around NetFlow is capacity planning, trend analysis, looking at the sources and volumes and trends in traffic to help you make sure that you're planning adequate capacity in your network. And also doing things like recognizing the traffic patterns as you're going across the internet, doing peering analysis. This becomes possible with NetFlow when you start mixing it with other data sets, things like BGP. So these are sort of offline but very valuable use cases for a little bit longer term. And then the last set, of course, is security operations. NetFlow gets a lot of use and a growing amount of use as a source of network security information, primarily because if you are using it in what we'll call an unsampled fashion, where you're getting a flow record for every connection that happens across your network, you now have a pretty complete record of exactly who is active on your network. It happens to be very good even without full unsampled flow at things like volumetric DDoS detection. Very easy to recognize that very quickly based on NetFlow. A lot of actually anomalous patterns of traffic and activity can be recognized using the NetFlow approach. So lots of ways that security is taking advantage of this. Some of these, we would argue, are as much network operations topics, like DDoS, denial of service detection, is as much an availability issue as it is actually a security problem. But you have certain mitigation steps and technology you want to take that are specific to that. And so you need to find the problems before you can try to deal with them. Now, back to why I have a couple of things starred at the top of there. It's our experience and my experience as an analyst watching the industry before I came over to work for Kentik, that live monitoring was not typically an active use case for NetFlow. And there's a variety of reasons for that. Mostly the tools that were being used were not really built for large volumes of streaming NetFlow data and turning that into something that could be clearly and cleanly put in an operations environment. It ended up being a tool that got used the next escalation up. So when a problem came up, network analysts, network operators would say, okay, now I will go look at the network data. We're getting to a point now with The sophistication of NetFlow technology, NetFlow analysis technology, where we can actually look at this as a live traffic monitoring stream. And consequently, the second item I have started there, which is automated alerting. Most shops that I would talk to over the years, whether they're using NetFlow or they're using packets, would not turn on alerts against these data streams. And the reason was they didn't feel that they could avoid too many false positives or too many false negatives. They didn't want to have another source of alerts coming at them. And so they simply wouldn't use the capability of most platforms to look for and recognize threshold crossings and patterns of activity. Well, that is definitely changing as we get more sophisticated analytics within the platforms that are available for taking on NetFlow. We're now getting to a point where you can be precise enough that such alerting becomes practical, and we have a lot of folks using our platform to do that today. Okay, so let's move on and talk about the tooling approaches and the tooling challenges. So when you now think about how are we going to start taking advantage of these use cases, what tools are we going to look for? What are the next generation options out there? And I'll start with talking about open source versus commercial. Now, we don't have time today to go through and list all of the actual product choices. We could probably spend a whole series on that. But I will say, just as an example, there certainly are plenty of open source tools out there for analyzing, harvesting and analyzing NetFlow. Things like Silk, things like PM Account, NFDump, NTOP, NG. There's a lot of tools out there. That's not open source, but there's a lot of tools out there that either are in or have come from the open source community that give you the opportunity to harvest and analyze NetFlow. There are also a number of commercial tools out there. A lot of them that have come traditionally from the enterprise side. There's a few that have come up, and less that have grown up in the provider space. They all have commercial tools, of course, will have some sort of license cost attached to them. Part of what you have to decide in looking at your choices is, what are the available tools? Do they have the scope of features that you need? And realize that open source, while it seems free from a license perspective, is anything but free from a total cost of ownership perspective. When you do deploy open source tools, you have to realize that you should make sure you have either good community support and or you really probably should have some dedicated admins and or even developers within your shop that can keep on top of the changing, the tuning, growing it, administering it. It's a non-zero amount of work. Now, commercial tools can save you from some of that effort. They may or may not be cost effective for what you need. So of course, every one of these sorts of evaluations has to include understanding current and future costs, both from a license and an operations perspective. So you have to think about both of these. Not trying to disrespect some of the great open source work out there, and also not trying to disrespect some of the aging commercial tools out there. But this is one of the decision points you'll have to deal with. Another one is thinking about how are you going to deploy this. Actually, there's a growing number of choices in terms of mode of deployment of NetFlow analysis tools. Historically, there has been sort of a two-tiered approach where there's a collector tier and then an analysis tier. And mostly with software, although there's a number of tools out there today that are very, very appliance-centric, almost definitely on the collector end of things, but also on the analysis side of things. It's not unusual at all to have offerings come out as appliances. But besides that, now there is a growing set of options to look at whether or not to even have and maintain an on-premises sort of deployment of these tools, or look for SaaS alternatives. So I think the important considerations as you're thinking about deployment technique are things such as what's it going to take to deploy and maintain this platform, this product, this solution, whatever I'm going to use. And then also consider sizing and scaling, not just current, but what could be future needs. And does either the appliance approach or the software approach or the SaaS approach, is it going to be able to scale, or is it going to become very painful? One of the things that's besides death and taxes that I think is another certainty in our corner of the world is that traffic will grow. And so you should certainly expect that you will not have less traffic and therefore less NetFlow in the future. You will have more. So make sure you understand what the potential for growth is, what the history of growth is, and what the likely rate of growth is going to be. The last decision point I want to talk about here is the use cases and whether or not some of these use cases are primary versus secondary. Security and network management, network monitoring, network engineering do tend to operate on slightly different sets of requirements when it comes to the NetFlow collection. If this is really a security-led implementation or project that you're looking at, then you need to be able to handle unsampled NetFlow volumes. And that's because in security sense, you want to see everything. You don't want to miss a single connection. From a network engineering and operations management perspective, it's just fine to work with sampled flow. And sampled flow means sampling on the order of every 1,000, 4,000, some cases even every 8,000 packets. It gives you the broad scale view of what's going on, but it's more than enough to get a sense for the larger volumes of things that you need to be concerned about. I will also advocate here, because I have been for years to various degrees of success, to at least consider making sure that whatever approach you take for NetFlow collection and analysis can be leveraged for multiple purposes. If you're harvesting NetFlow, there's no reason why you shouldn't be collecting once and using or analyzing many, and serving as many different audiences as you can with that same set of data. So NetFlow can get used by multiple groups. There's no reason not to try to find a way to leverage the investments you make in a similar manner. So secondly, the last point I want to make about the tooling challenge, one of the big challenges that I think has been faced with NetFlow, and one of the things that's limited its utility for the the real troubleshooting and forensic use cases, is the fact that most tools out there would tend to summarize. And that means as NetFlow would come in, it would be taken apart, turned into metadata, and consolidated for storage long-term for history. Now, of course, this gives you more efficient storage. It does allow you to compress. If you're getting a million flows a second, storing all of that is difficult. So a lot of tool vendors in the past, for very valid reasons, made the decision that no, we won't. We'll summarize data. We'll aggregate data. We'll cook it down into a more compact format, and that helps us save disk, and it makes it faster to look back at what we see in history. The downside of this is you lose some really, really important and essential detail in the process. And in particular, you lose the ability to go back and really explore what information has been given to you. So as a result, we find more and more folks who really don't want to summarize at all. They would vastly prefer, if possible, to be able to keep all of the raw data coming in, because you never know for sure that you have the data you need, and then you won't want to go look through the data as it came in raw to understand or characterize a problem or dig into it. So this has been a challenge. Most technologies that have been developed 5, 6 years ago or longer have not really, it's not been practical to do anything but summarize. But now we're in an age where we've got some new choices, and that's kind of key to what we're going to talk about next, big data and SAS. And that really does change the landscape of what's possible. So let's start with talking about big data. And why are we talking about big data here? Well, as I said here, and I've written about this quite a bit in the past, it's my contention that network management data, network monitoring data absolutely always has been big data. If you think about the way big data is defined in general in the industry, it's typically the 3 V's. What's the volume? How much of a mix of data in terms of variety is it? And what kind of velocity is that data coming in? Big volume where it's all in one file and you move it once a day? Maybe not. But when you're streaming data in, as we see with NetFlow, hitting millions of records a second, billions of records a day, we've got both volume and variety. Now, volume and velocity. Variety is more of a factor when you start to think about the fact that NetFlow is, while extremely valuable, is certainly not the only set of data available from network monitoring. And when you start adding in other sets of data, when you start adding in log data, when you start adding in BGP data, you start adding in SMP and time series data, there is absolutely variety to be countered with, to be dealt with in the network monitoring realm. So we think it fits a traditional big data definition. And there's also been some really great things happening out there around big data. Big data architectures and technologies have advanced. They've become more stable. They've become more flexible. The tool communities and ecosystems around there are improving. It's really proven to be quite good for any sort of mixed data sets. Now, big data originally had most of its applications in the business intelligence and business data analysis arena, but there's no reason why you can't apply these newer approaches and technologies to the network monitoring and security monitoring challenge. And we're seeing more and more of that. We're seeing plenty of that today in terms of tools that are being applied this way. I want to share with you a little bit of data, which, full disclosure, I'm a little biased towards. Before I left Enterprise Management Associates, I actually authored a study on impact of big data on hybrid infrastructure management to look at both what big data meant for internal IT as well as the practices. And it was completed by my colleague, Seamus McGillicuddy, and published in June last year. But I went back and I looked at the results, and I found some really interesting correlations to the things that we were just talking about today. So the first was this question about, what practices out there are being supported by big data analytics, what management practices. And sure enough, the top three that came back in this results were exactly those three use cases we talked about earlier. There's infrastructure planning, there's operations monitoring, and there's infrastructure security. Big data absolutely being found to be valuable against these use cases. And therefore, I think it becomes incumbent on us to really look at how we can leverage big data with NetFlow, since NetFlow is addressing exactly these same three use cases. The other one I wanted to share was more about the whole variability point and the fact that there is a lot of monitoring data that can be gathered and added into your analysis, your scope of analysis and your analysis systems. So one of the things I built into this research and asked and wanted to find out was, what are people putting in there? And interestingly, APM data ended up first. Now, there's a lot of enterprises that were answering this particular research. But right behind it, essentially tied for second, were the other types that I talked about earlier. Flow data, log entries, syslog, as well as time series performance data, things like SNMP. So the other thing that's not on this slide, but if you looked a little deeper into the data, and one of the things Seamus did with us, he looked at a variety of responses based on the sophistication and the experience levels with big data. And the more experienced shops were with big data technologies, the more likely that the difference between APM and those tied for second, that gap narrowed significantly. And pretty much everyone who had more experience than less was treating those groups fairly equally. So we're seeing good results, we're seeing good interest, and seeing good reasons to look at big data as a way to handle NetFlow. The other half of big data plus SaaS is SaaS, software as a service. So why should we be thinking about that right now? Well, part of it is also, just like big data, it's becoming mainstream, but it really, truly is mainstream. Now, most of us, of course, know of Salesforce, and Salesforce has been the big ship plowing the waters of the application bay, if you will, and being very successful. It's huge, and a lot of other companies out there have been just riding their wake. But the result has been pretty broad acceptance of SaaS as not only a viable way to access business critical applications, but also secure enough that business critical data can be stored in a SaaS backend. And so that's leading to adoption across other sectors, not just CRM, but now human resources, financial management, materials resources, you name it. Every application sector can now be pretty much consumed using a SaaS model. In fact, some of the numbers are starting to become really pretty powerful. I threw this one data point in here I ran across recently from Gartner. Now, this is about an office tool, not necessarily an IT monitoring tool, but they're finding 72% of enterprises using or planning to use cloud office systems. I think that fits the definition of mainstream. So SaaS has become a real way to access technology. It actually also is becoming more and more a real option for network and infrastructure management tools. So I think a lot of the early success here has been in the log management space. Certainly guys like Splunk, who did not start in SaaS, but does have a SaaS version of what they do, has been working to plow this ground. But then there are born in the cloud log management guys like Sumo Logic and Loggly, and there are a bunch of others. I'm not going to try to name them all. Have really done a good job of establishing a clear success story around SaaS for IT management type data. Network management tools have been a little slower to move in that direction, but there are some great examples out there. I would say AppNeta was probably one of the most earliest progenitors of this. They were originally called Apparent Networks, and remade themselves and turned themselves into really one of the first SaaS-oriented performance monitoring platforms, and have done great things there. But now we have other tools, guys like Logic Monitor, who are a general purpose fault management platform. They also do some SDP harvesting. We'll do a little bit of NetFlow too. They're pure SaaS, born in the cloud type model. Guys like Auvik, also just starting up and serving the MSP community, pure SaaS models. So we're moving there pretty quickly, and more tools are starting to become available in a proper SaaS model. Now, I will say one quick thing here about what is SaaS and what is not SaaS. So taking a tool that would be deployed on your premises and simply dropping it in a VM on a cloud and making it available to you that way, that's not SaaS. That is cloud hosted. And I realize it's a little bit of a subtle line to draw for most people. SaaS means proper SaaS has been built to operate as multi-tenant and as data management architecture that is designed to be very service-centric. And so tools that are designed to be SaaS are fundamentally different from non-SaaS tools that are simply cloud-hosted. All right, so what if we put these two together? What's interesting about that? Well, I think it's really interesting to think about this because the techniques and the technologies that big data brings you are great, but there is a non-zero cost to deploying a big data solution, a back end. There are substantial impacts. That research I talked about from EMA, one of the things we were looking at is, how big of an impact is our big data projects having on compute, on storage, on systems, on all of the traditional work of the IT group? And the answer was significant and growing. So if you want to deploy big data, great, be ready for it. It's not cheap, it's not free. You're going to have to dedicate some resources to this. So if you could have a SaaS provider bring you the power of a big data architecture without making you have to worry about all this, that can be a big win. Let someone else stand it up, let someone else worry about the scaling, about the reliability, the performance, and the uptime. That's a big, very powerful combination to look for. If you do buy this, what I'm selling you here about this combination, you should look for, especially when you start looking at this combination, applying it to NetFlow analytics, make sure it's got a few of these qualities. So it has to be able to handle very, very high-speed ingest, and especially with the sort of growing rates of traffic that we see, the fact that this is a growing volume of data as well. As we add more enrichment to the flow data, we will get more and more detailed metrics, but it also grows the volume of what's going on from a storage perspective and a capture perspective. I'm saying full lossless data capture here. Now this goes back to the point that I made earlier about summarizing flow data as it comes in. Ultimately, if you are going to use a big data architecture, one of the objectives is you don't have to do that. You should be capturing and saving all of the raw data. Let the big data architecture worry about the management of all of that data and giving you back information about it. And don't worry about trying to summarize and turn it all into metadata before you put it in the back end. So make sure that whatever you're looking at can handle and retain full raw NetFlow. It's good, if possible, to find solutions that can start giving you support for things other than just NetFlow data, because the real power comes not from just NetFlow, but NetFlow Plus. When you start crossing it and correlating it with other sets of data, you get some really, really cool results. Another point that's really important here Not only should these kind of platforms have the ability to take in a lot of data without hiccuping, it should also be able to turn around and answer your questions about that data as quickly as possible. And so rapid response, very important. There's a lot of time and effort spent in a lot of the on-premises tools to try to improve response. And this is one of the hurdles. A lot of the big data architectures out there today really aren't designed to handle sort of real-time queries and real-time results. There's improvements happening out there for sure, but a lot of the original architectures really weren't. And lastly, we think it's very important to have direct access. Total unrestricted access to your data. Grab it when you need it for whatever reason you need it. Unfettered access is really the name of the game these days. So let's move over to talking a little bit about an example of the things we're talking about and the way that Kentik has implemented a solution. I'm not going to spend a lot of time on this. I'll just give you a few examples and talk about sort of the parallels between the points we were making today and what Kentik's doing about it. So we have a little sort of tongue-in-cheek image up here. Our goal, of course, is to deliver solutions that suck less than other solutions. We have not yet achieved, though we aspire to not suck. But we think we're bringing this suckometer down to very low levels once we start applying some of these cool new technologies like big data and SAS to the problem. So quick view from an architectural perspective. I love architecture views. Being an ex-analyst, it gives you a quick grip of what's going on. Generally speaking, what we're doing here is we're taking in streaming volumes of flow data, but also SMP data and BGP data into the backend we call our Kentik Data Engine. This is our big data backend. And then that's hosted in the cloud. We run that backend architecture. We build it. We buy the servers. We buy the storage. We provision it all. And we have an ops team that just watches it every single hour of every single day, every single minute of every day. And then we make that data available to you across the web via a portal. We run automated alert checks against us to watch for anomalies, things like DDoS detection, but lots of other scenarios as well. And send you alerts. And then we also have a direct open API. So you can either use standard Postgres to pull data. We have RESTful wrappers for that too. A little bit of a deep dive into what we mean by big data, so you understand the terms we're using. So the KDE, Kentik Data Engine, is our big data engine. And in the back, we have a 3-tier architecture so that we can scale. It's clustered, it's redundant, it has built-in load balancing so that we can handle not only extreme high volumes of ingest of data, as I mentioned earlier, billions of records a day, 20 to 25 billions of records a day as of sort of the 1st of January. It keeps growing. But we can also handle very rapid and very fair and very quick responsiveness when either automated queries are run against this backend to look for patterns of activity of raise alerts, or for people who want to run analyses and explore the data. So we shoot for a couple seconds at most to an answer to any question that you might pose to the backend, and we hit that more often than not. So what it looks like then, if you are leveraging this big data backend, you're putting your data in. Our portal interface is designed to allow very intuitive and rapid navigation of that data, easy surfing of data, very quick to build and add multi-stage, complex filters to narrow down and find the things you want, but then also an ability to just with trivial steps to flip and pivot and look at it from a different angle, or look at it a different metric once you've narrowed down the data set that you have. So that's been a big focus. The founders of Kentik all have many, many years of experience building and running very large networks. And so they built the front end that they wish they had so they can navigate this data quickly and easily. And it really pays off in terms of the result that we've been able to achieve. We do, of course, have dashboards so you can see high-level views of what's going on. Lots of changes coming there, but they're designed to give you the quick sort of knock view of activity. And then we also go down into some depth around peering analytics. It's first of our really applied set of features. I mentioned that BGP is a good set of data to add to and correlate with your NetFlow. If you do, you can get these sort of results. You can see flows of traffic, but then understand the paths those traffic are taking between your network and your end customers or your partners or whoever else you're dealing with. So this is a hop-by-hop volumetric flow analysis that we can run. It's very flexible to look at it from different angles to understand is your peers, the points of presence you're connecting to, are your transit providers, are they behaving the way you expect them to or not? Are there opportunities for more efficiency? Are there opportunities for improving your cost structure? Are there opportunities or potentially needs for you to find a better way to reach certain groups of your customers, for instance, that are taking too many hops to reach? Lots of answers you can get in a very visual form, very intuitive form of looking at this. So this is the kind of next-gen analytics we're looking for, not just top toppers, but let's see more about what this is telling us about the behavior of the network, about whether it's acting the way we expect, where the problems are, and how we can go about solving them. So a quick wrap up, and we'll save a few minutes here for questions. I hope what you've heard today is some assertions that that we really do believe that NetFlow Analytics should be doing a lot of and things for you. It should be handling your offline capacity planning and really truly handling your live monitoring needs. It should be meeting use cases and needs for both the NetOps community as well as the SecOps community. There's no reason why it can't. And it really should be also giving you more and more increasing amounts of context about the applications and services being delivered, not just the volumes of traffic. And then lastly, from a technology perspective, you should look for solutions that can gracefully scale and handle not only really large volumes of data with no summarization, but then also turn around and be able to answer the questions you want to ask against it quickly. We need to move all of this out of the best effort 5 to 10 minute time frame into the okay, we need answers, we need them now, we need them in seconds, we need to recognize things happening in the network, in a sub-minute time frames. And that's a challenge, but it can be met with big data technologies. SAS really becomes an increasingly hard to ignore in terms of an effective and widely accepted means for accessing these complex applications. Definitely worth thinking about in terms of the total cost of ownership there. And we think it's a really powerful, you can combine these two together. It really does put you in the realm of having a platform that can not only start delivering you, but be the platform for the future for next-gen NetFlow Analytics. So thank you very much for your time. I hope this was informative. I'd like to turn it back over to Alex to see if we've got any questions that have come in.
All right, thanks, Jim. Let's see here. We do have a couple of questions, and if folks have any more, please feel free to tuck them in now. One question is, what other big data backends are being used to store NetFlow?
That's a great question. This is really interesting because we have a lot of conversation with folks who, as we first talked to them, they were already trying to do this on their own. They're trying to take NetFlow data and stick it into Hadoop or, to using things like Spark, using things like Elastic to push their data in there and then figure out how to get good things out of it. And you can put NetFlow data into all different sorts of big data backends. What we've seen the challenge be is figuring out how then to get the right data back out of it, how to find the information you need, and how to sort of go beyond, okay, I can run reports on it now, that's cool, to how do I set up some sort of effective alerting regime? How do I recognize patterns of activity in there that really do indicate something I have to worry about? So we've had a lot of conversations that go something like this. Hi, we're Kentik. We're using big data. Now, this is the kind of views we've done. And the folks we talk to say, oh, cool, we have a big data project. We have big data expertise. Thanks very much. Very interesting. We'll build it. And then a couple of weeks or maybe a couple months later, they come back and they say, that was really hard. And while we got a few things working, we are a long ways from getting everything that you guys have in place. Let's talk again about what you did. So it's not for everyone. It certainly is possible to bring your own big data. You just have to decide if this is going to be a science project, if it's going to be something you can practically achieve and maintain, or if you need a quicker path to solution.
Okay, great. Thanks, Jim. Another question is regarding how, I think is specific to Kentik, how do you get NetFlow data into your SAS backend, and how do you secure that?
Oh, yeah. Okay, good question. So one of the things I didn't mention about SAS, I think I did mention about the fact that it's becoming more and more common that SAS is an acceptable from a security perspective. A lot of folks are very worried that, hey, I don't want to have my data out of my control. So first of all, if you're using SAS anywhere in the organization, especially if you're using it for things like CRM like Salesforce, or using HR like Workday, there's a lot more sensitive data than what you're going to see in NetFlow being already put out into the cloud somewhere. But basically, we make it a variety of techniques available for people who have various different levels of risk tolerance, I guess is the way I'll put it. We have probably 30–40% of folks just send the NetFlow records right to our public IPs. But then we have a lot of people who are actually using our very small, compact, on-site proxy agent to send that data to. We then wrap it in HTTPS before we send it to the back end, so it's secure and encrypted. That's a very common way to do this. We also have a few people who are taking advantage of our presence and their presence in an Equinix facility to do a direct private network cross-connect. And so the data is traveling over a private wire. And that's another way to make sure that the data stays secure.
Okay. Ancillary question to that is, what if you can't actually use a public SaaS? Is there a private option?
Well, there is. We are working on how we do this best and most efficiently for everyone, but we have actually we have engagements where we deployed our system on customer premises if we just can't get past the public SaaS model. We actually much prefer people to use the back end that we have because we built it, we scale it, and we can be much more assured of guaranteeing performance than what we do on site. But we realize and acknowledge there will be some cases where it just really can't leave premises.
Okay, so last question I've got is, isn't SAS just as expensive as other commercial tools? I assume referring to on-premises tools.
Yes. I'm sorry, not yes to the question, but yes, I agree with your reading of that. I would assume against commercial tools. So that's a really interesting question because the way that you buy a SaaS, and this is getting a little out of the technology, more on the business side of things. SaaS typically is looked at as an operational expense. So it's a recurring operational expense. Almost all SaaS solutions will charge you a recurring subscription. Whereas most other commercial tools out there that are not SaaS will be sold to you as a one-time license charge plus recurring maintenance fee. So maintenance fees get bundled into the subscription price of SaaS. So while if you look at the upfront cost of SaaS solutions is usually far less than the upfront license cost of commercial tool, it is worth looking at the long-term cost of the systems required for on-premises, the capital that you will require not only for initial deployment but potentially refresh of appliances, the depreciation of those, and think about the entire financial side of total cost of ownership. And I think that's kind of what I would lead back to. There are some cases where SaaS would be more expensive than a commercial tool. But it depends on which tools you're talking about, and depends on making sure that you are accounting for the total cost of ownership, both near term and long term. And I think most of our experience has been that it's significantly less expensive than especially appliance-based solutions because of the capital costs you avoid, because of the fact that when you go to scale and grow and update, the operational costs are essentially very, very much less. So some cases could be, your mileage may vary, but I think it's at least no more expensive, and in most cases, much less expensive to go with the SaaS route.
Okay, well, thanks very much, Jim, and thank you everyone for attending today. This webinar is recorded and will be posted soon to our Bright Talk channel. So if you want to share this or come back and cover some points that you maybe missed at the beginning, you can come back and do that. So thank you very much, and everyone have a great day.